want you to think about a bushel of apples. Maybe 2 bushels of apples. I'm going to call the first bushel A1, and A doesn't really mean anything, it's just a term. And in this example, it stands for apples, but it could be any other letter or anything. But the 1 just tells you that it's the first bushel. So the second bushel I would call A2. Maybe there's a third. I'd call that A3, and you can probably see the idea. A4 is the fourth bushel, and A5, and so on and so on and so on. This is called a sequence. And in this example, we have a sequence of apples, but it might just as well be a sequence of numbers. We're going to be concerned with what happens in the future. And so if you look at the one all the way on the right, it might be the 10th bushel of apples, or the 99th, or the 26th, or anything. We don't really know sometimes which bushel that is. So we use a variable like n to say it's just the nth bushel of apples. Maybe it's the 10th, maybe it's the 20th, I don't know. So what about the bushel right before that? What comes before n? N minus 1. So think about it. If n was 20, then we're talking about the 20th bushel of apples. The one right before that, 20 minus 1, is 19. So what comes right before that? Well, right before n minus 1 is n minus 2. We're going to need to talk about the bushels in these terms sometimes. We're going to talk about some term in the future in terms of something in front of it and something in front of that. Well, we like to do those, look at numbers. So let's say that the first bushel of apples has 10 apples in it. And that doesn't give us a whole lot of information, but think about the second one. Let's say there are 12. Okay, I'm starting to get an idea of what's happening. And then the third bushel contains 14 apples. By now you probably can predict what's going to be in the fourth bushel, 16, and by now, are you getting it? Do you know how many are in the fifth bushel? 18. Okay, great. This is called an arithmetic sequence. An arithmetic sequence is where a certain number is being added. In this case, you probably figured out that to get from one number to the next, you're just adding 2. So if we're adding a number, plus 2, plus 2, plus 2 every time, or subtracting a number, minus 5, minus 5, minus 5, if it's the same thing every time, if it's added or subtracted, that's called an arithmetic sequence. So a couple of examples. Number 1, find the common difference. All they're asking you to do is look for the pattern. The first number is 21, and we're going to the second number is 29, and then 37, and then 45. All you have to do is figure out how you're getting from number to number, and it looks like you're adding 8 to get from one number to the next. And so the common difference, D, equals 8. Number 3, find the 3 terms in the sequence after the last given one. I like to think of it like this. Fill in the blank with the next 3 numbers. Well, it's really similar. We want to figure out how we're going from number to number. And it's probably easier to see about right here that we're adding 10 every time. Add 10, add 10, add 10. And so if you continue that pattern, you can add 10 and find the next numbers 33, and then 43, and then 53. Problem 5, same deal. Find the next 3 terms in the sequence. So again, you have to figure out what the pattern is. How are they getting from number to number? And in this case, it looks like they're subtracting 5. Negative 11 minus 5 is negative 16. Subtract 5 to get to negative 21. Subtract 5. So it looks like we're subtracting 5 for this pattern. And so the next number, if you subtract 5, you're going to get negative 31, negative 36, negative 41. These are arithmetic sequences. That's because on number 3, I added 10 every time, and on number 5, I subtracted 5 every time. Now we're going to find the recursive formula. Remember that word. That's important. That's going to tell you what to do and how we do it. So if we think about the bushels of apples and put it in those terms, we're trying to find the formula for AN. So the answer is going to be AN equals, and we're going to use the term right before it and the first term. Those are the things that we're going to need, all right? So if you look at the numbers in this sequence, you should notice pretty quickly that you're adding 7 to get from number to number. And so whatever number it is off in the future here, in order to get there, you must have added 7 to get there. So think about it in terms of the bushels of apples. For the nth term, you need to take the one right before it, which is AN minus 1, and add 7. Now that seems like it's finished, but you have to also tell me where we started. So say A1 equals 1 here. It means you need both of those statements in order to have a recursive formula. If you didn't put that second statement, if you didn't say A equals 1, then you wouldn't, you might have a repeated answer. If I said 0, 7, 14, 21, oh my gosh. If you notice, that's the same pattern. You're taking a number and adding 7, adding 7, adding 7. And so it would be that same top step, but we have to have that second step, A1 equals 1, to eliminate any other possibilities of the numbers. So that's a recursive formula. In order to find that nth term, you need the term right before it, and that common difference, and the first term. So look at the next example. From 14 to 5 to negative 4 to negative 13. Looks like they're subtracting 9, right? So the recursive formula, A in minus 1, and then subtract 9. Second part of this recursive formula, you got to tell me where we start. A1, that's the first bushel of apples. A1 is just this first number, 14.